Okay, in this lesson on exponents, we are going to be practicing our division properties. But before I do that, I want to go ahead and I want to just review real quick what we learned in the last section. So I'm just going to give us an example here. Okay, so let's just say that this is my problem right here. Since my parentheses are smushed together, I know that I'm multiplying. So I start off by multiplying the coefficients. So I multiply the 3 times the 4, and 3 times 4 makes 12. Then I multiply my a's together, and we learned in the last lesson that whenever you multiply the same base, they both have a base of a, whenever you multiply the same base, you keep that base, whatever it is, and you add the exponents. 2 plus 5 is 7. Then I go to multiply my b's together, and same thing, whenever I'm multiplying the same base, I keep that base and I add the exponents. Remember, this b has an exponent of a 1, you just don't see it, and 1 plus 7 is 8. And that's my answer. So that's just a little recap of what the last lesson was about. We were multiplying, and when you multiply the same base, you add the exponents. Okay, so today we're going to be dividing the same base. So in this example, you can see that the number under the exponent is an a. So a is the base, and as long as we have the same base here, the answer will be whatever that base is, and then you subtract the exponents. So when you're dividing, you subtract exponents. And it's very important that the bases are the same. If this was an a and this was a b, we couldn't do it. So if we have coefficients out in front, let me just show you an example over here. Let's say I have 4a to the 6th over, say, 10a squared. If I have coefficients, which I do, I'm going to divide them. 4 divided by 10. 4 divided by 10 doesn't divide nice, but I can reduce it. I can divide both of these by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So if we have coefficients, we divide the coefficients. And then as long as we have the same base, we keep the base, whatever it is, and we subtract the exponents. And 6 minus 2 makes 4. So the answer would be 2/5 a to the 4th. Okay, so if we have coefficients, we divide them, and then we subtract the exponents. All right, let's just practice. So in this first problem here, remember the number under the exponent's the base, and as long as I have the same base, my answer will be that base, whatever it is, and then I subtract the exponents. So what is 6 minus 3? 6 minus 3 is 3. And then I can actually work this out. 2 to the 3rd means 2 times 2 times 2, which is how much? 8. And that's our answer. Okay, so the number under the exponent's the base. As long as I'm dividing the same base, I write that base down, whatever it is, and then I subtract my exponents. 14 minus 6. And how much is 14 minus 6? 8. So I have a to the 8th. Now this I can't calculate because I don't know what a is. I don't have a value for it. So that's as far as I can go. Okay, number 3 practices the coefficients, like I talked about a little bit ago. So if you have coefficients, then you go ahead and you divide those. So what is 6 divided by 2? 3. But then when it comes to the variables, remember the number under the exponent's the base. As long as I'm dividing the same base, you write that base down and you subtract the exponents. And what is 5 minus 4? 1. So I have 3a to the 1st power. And then the b's, I write that base down and I subtract those exponents. 6 minus 3. And how much is 6 minus 3? 3, so I have b to the third. And then I can write this without that 1 for an exponent. It's just understood to be there. So 3ab to the third. And there it is. So right now I'm trying to show you all my work, but eventually I won't do that. All right, so this is dividing the same base. Whenever you're dividing the same base, you subtract the exponents. Whenever you're multiplying the same base, you add the exponents. Okay, and then here is our law for our negative exponent. And it's kind of a strange rule, but a to the negative 1 is understood to be 1 over a to the first power. That's the rule. And in class, I'm going to show you why it does work out to be this way. I'm not going to show it right now, but I'm going to show you in class so I can get some of your feedback. So basically, this is the thing about negative exponents. If something has a negative exponent, we're going to move it. If it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. So I'm just going to write a little rule over here. If something has a negative exponent, move it. If something has a negative exponent, move it. So I'm going to show you 2 examples before I actually do the examples on the paper. So let's say I have x to the negative 3, y to the negative 5th over z to the negative 2. Anything that has a negative exponent is going to move. So since x has a negative exponent and it's in the numerator, it's going to move down to the denominator, and once it moves down there, the exponent switches to positive. Y has a negative exponent, and since it's in the numerator, it's going to go down to the denominator, and once it's down there, it's going to switch to a positive exponent. Z has a negative exponent, and since it's in the denominator, it's going to go up to the numerator, and when it goes up, it's going to have a positive exponent. And that would be the answer. So if something has a negative exponent, we're going to move it from numerator to denominator, from denominator to numerator. Okay, I ran out of room to show you more, so let's just get to these. All right, does 4 have a negative exponent? Nope, keep it where it is. Does y have a negative exponent? Nope, keep it where it is. Does x have a negative exponent? Yes, so we move it. Right now it's in the numerator, so it's going to move down to the denominator, and when it moves down there, the exponent switches to positive. And there's our answer. Now, since these are different letters, I can't do anything else. If this was an x and this was an x, I'd keep going. All right, let's look at number 5. Does the 11 have a negative exponent? Nope, keep it where it is. Does the m have a negative exponent? Yes, it does, so we move it. It's in the numerator, so I move it to the denominator, and when I move it down, the exponent switches to positive. Okay, number 6. The only thing that has a negative exponent is the w, so since it's in the denominator, it's going to move up to the numerator, and when it moves up there, the exponent switches to positive. And that's it. I don't even have to do anything with that 1, because 1 times w to the 4th is still just w to the 4th. So that's the negative exponent. If something has a negative exponent, you have to move its location. And like I said, I'm going to show you why that is in person in class. Let's flip. Okay, so now we're going to put it all together. We're going to put together the division rules as well as the negative exponent rules. So as long as I have the same base, I keep that base whatever it is, and then I subtract the exponents, 3 minus 6. That's what you're doing when you divide the same base. So what is 3 minus 6? Negative 3. So we can't ever leave something with a negative exponent. Since this is a negative exponent in the numerator, it's going to drop down to the denominator. When it drops, the exponent switches to positive. If nothing else is up here in the numerator, we have to put a 1. And that's our answer. Okay, number 8. I'm going to start with my coefficients, and I just divide my coefficients just like we learned back in 3rd, 4th grade, what's negative 18 divided by 3? Negative 6. And then when I go to do my k's, I write down the base, whatever it is, and I subtract the exponents, 3 minus 3. And how much is 3 minus 3? 0. We'll talk about that here in a second. Then when I go to do my p's, I am trying to divide the same base, so I keep my p, I keep that base, whatever it is, and I subtract the exponents. Remember, this has an exponent of a 1, you just don't see it. So what is 2 minus 1? 1. Okay, does anything have a negative exponent? No. This is a negative 6. It's a negative number, but the negative 6 doesn't have a negative exponent. So since it's just a negative number, it just stays where it is. And then we learned something special last class about anything raised to the 0 power. Anything raised to the 0 power is 1. And then p to the first, that's just p to the first, but I don't have to write it. Well, how much is negative 6 times 1? Negative 6, and then I just keep the p. And my answer is negative 6p. So remember, anything raised to the 0 power is 1. And 1 times anything is whatever that anything was. Okay, let's try 9. Let's start with our coefficients. So 4 divided by 12. Doesn't divide nice, but we can reduce it. What is 4 divided by 12? 1/3. Okay, so now I'm going to work on my r's. Whenever I'm dividing the same base, I keep that r, and I subtract the exponents. What is 2 minus 7? Negative 5. And then when I go to do my s's, I keep that base, whatever it is, and I subtract my exponents. What's 4 minus 2? 2. Now let's clean it up. Since r here has a negative exponent, it's got to move. So it's going to go down to the denominator, raised to a positive 5 for an exponent. The s had a positive exponent, so it doesn't need to go anywhere. It stays on top. The 3 had a positive exponent, so it stays where it was. It stays on bottom. And this 1 that was right here, I could put it back in front, but I don't need to. And this is it. I'm done. Since I have an s up top and an r on bottom, I can't do anything else with those. So that is my answer. Okay, number 10. I'm trying to divide the same base, so I keep that base, and I subtract the exponents. 4 minus negative 4. And remember, the minus the negative back to back makes a big plus. And how much is 4 plus 4? 8. So I have h to the 8th. No negative exponent to worry about. Okay, number 11. So I'm trying to divide the same base, so I keep that base, and I'm going to subtract the exponents, negative 1 minus 5. I'll just show you my work here. When I go to do my d's, I keep that same base, the d, and I subtract the exponents, 3 minus negative 3. So let's clean this up. How much is negative 1 minus 5? Negative 6. And then remember, the minus the negative turns into a plus. So how much is 3 plus 3? A positive 6. And then remember, if something has a negative exponent, it has to move. So since the c has a negative exponent, it's going to go down to the denominator. Once it moves down there, the exponent switches to positive. Since d has a positive exponent, it's going to stay on top, just where it was. And that's it. That's our answer. Okay, number 12. I'm going to start with my coefficients. Negative 4 divided by 16. It doesn't divide nice, but it does reduce. What does that reduce to be? A negative 1/4. Okay, let's go ahead and work on the a's. When I write that same base down, what do I get when I subtract the exponents? Remember, this has an exponent of a 1. You just don't see it. 3 minus 1, 2. Now I'm going to subtract the exponents on the b's, so I write that base down. And what is 1 minus 4? Negative 3. And then when I go to subtract my exponents on my c's, what is 1 minus 1? 0, so I have 0 to the 0. And then there's no other d to work with other than the d that's in the numerator, so it's just going to stay right there. So let's clean this. So first of all, I'm going to go ahead and I'm going to write it like this. I'm going to put negative 1 on top and 4 on bottom. A has a positive exponent, so it's going to stay in the numerator. B has a negative exponent, so it's going to drop to the denominator. Remember, anything to the 0 power is a 1. So if I put a 1 here, 1 times this is still just this, so I don't even do anything with it. And then D has a positive exponent, so it stays up top. And that's it. That's my answer. Not too bad. Smiley face. We're done with this one.